Okay, so this first section is kind of a lot of vocab, so bear with me. We'll be patient as you write things down, but we have to get all this groundwork laid before we can jump into the rest of the year, because we're going to be using these terms all year long. So first of all, let's do point and space. So a point has no size, but it gives you a location of something. And we always name it with a capital letter. It's hard to see this on the screen because it looks yellow, but that's the important part. That's the part you're going to be doing in your homework, is naming things. So know that if you're ever naming a point, it's with one capital letter. Space would be a set of all points, like everything in the air, the desks, the floor, you, me, everything is considered space. And they aren't really definite terms because they're hard to define. That's why they're called undefined terms in geometry. Okay, next one is line. This is a set of points that extend in opposite directions. So all these points lined up in a line, and they're going to go forever in opposite directions. The important part here being how to name them. So you can name them with 2 capital letters, highlighting this so you can read it from far away, or 1 lowercase letter. And they would give this to you. If that's the option that they're going to use. They would give you a lowercase letter on the end of that line. And I'll give you an example of that later. Actually, we could just draw one right here. So let's draw a line. Put LM right here and put a lowercase g on the end. So we could name this line as 2 different ways. With 2 capital letters, we could name it as LM or ML. Doesn't matter the order. Or line G. 3 different ways to name lines. Somebody want to tell me why we use those 2 arrowheads when we talk about lines? Yes.
Show that they extend forever.
Forever and ever. There's no way that we could draw it forever and ever because our paper's not big enough. Nothing is big enough because it goes on infinitely. So we put those arrows on there to show us that it's going to go on forever and ever. All right, we have one picture to add to this discussion on lines. So we have that line with X, M, and O on it, and I want 6 different ways to name that line. So I need 6 different people to help me out. All you have to do is look at these rules up here. I gave you 2 examples up here. As long as you follow this rule right here, it's going to be hard to get it wrong. Because we only need 2 things. Somebody be brave. Yes. OX. It's another way. It's 5 more. Yes. 4 more. New people. Mm-hmm. Mm-hmm. 3 more. Mm-hmm. X. Yep. And somebody new, give me the last one. Mm-hmm. So it does not matter the order you pick the letters, what letters you pick. You just have to pick 2 letters on that line, and you've named that line. And then I'll know exactly what you're talking about. Questions on lines at all, or points? Anyone who has to leave early for sports, your assignment will be on that homework sheet I gave you, just so you know that. Questions on this page? Anyone still need this page? Okay. A couple more words to know. Segments. This is the part of a line that consists of 2 endpoints. So I will get a picture up there as you are writing that. 2 endpoints does not go on forever in both directions. Can put 2 letters on there. How do you think we could name this? You think it could go both ways, AM or MA? Would that be the same segment? Just like with lines, it doesn't matter. So we've got AM, but we don't put arrowheads. We just put that segment above it. Or MA. Array. This has 1 endpoint. So only one of them stops. The other one goes on forever. So this one has an endpoint on one side, but not on the other. So this one we would name as XB. Now, if you don't have the notes printed out, you don't need to write these next 2 questions down. They're more for discussion. This one you should already know the answer to. Is AB the same as BA when they're segments? Yes. Okay, that does not matter. Same question here. Is LM the same thing as ML when we're talking about rays? How come? Only one goes on forever. This one is saying that M is going to go on forever in that direction. This one says that it's going towards L. So this one up here, what I do want you to write is BX with a line through it saying you cannot name it that way. Rays are the only ones that you have to be careful which order you put your letters in. Questions up here on the top? And again, notes won't typically be like this where it's so much vocab, but we just need to lay the groundwork for the rest of the year. Anyone still need this for the top stuff? All right. Opposite rays. 2 collinear rays with the same endpoint. Now, collinear, probably a word you haven't seen before. That means in a line. And we'll get a picture to go along with that. I'm going to put them in two different colors. So we've got ray LX and ray LM. Those are opposite rays. They start in the same point. That endpoint is the same as L, and they point in opposite directions. So two opposite rays. So a non-example Tell me why that is a non-example. Why are those not opposite rays? Yes. Exactly. Okay, they're not perfectly going in opposite directions and they're not on a line together. They're kind of at an angle. So even though they have the same endpoint, they're not opposite rays. If you don't have the notes printed out, you don't need to write this down. But if you do, you can fill it in. More for discussion on this one. So if we have this picture right here, what are 4 different rays that you see that we could name? Yes.
BC.
BC is one of them. Starts here and goes in that direction. Ray BC. Yes. AC is another one. Yes. AB, I'm going to put with this one because they are the same ray. Another one. CA. Somebody new. There's one left. There's 2 left. One of them is the same as CA. Yes. CB, the same as that one. So what is the one last one that's different from all these? Yep. So there are 4 rays. Why? Can you see why CA and CB are the same ray? Yes. They're doing the exact same thing. They both start at C and they're both going in the same direction. Okay, so just know that those are the same, but those are 4 different rays. Okay, let's do a picture definition. Sometimes I like to do this because it's a little bit easier to understand. And we already know the definition of collinear. We put a very short definition up at the top. Collinear means in a line. So collinear points would look like they're in a line together. Non-collinear would be not in a line together. Plane. Another vocab word. We're almost done with the vocab, I promise. plane is a flat surface that extends in all directions, so it's like a piece of paper that keeps growing and growing and growing and getting bigger, but it never grows up or down. It's just a flat surface that is enormous. Again, most important part as far as homework goes, named with one capital letter or 3 non-collinear points. That's the important part that you'll need to know for the homework. One capital letter or 3 non-collinear points. So for instance, when you see planes in your homework, they'll typically draw a parallelogram so that it looks kind of three-dimensional, like a piece of paper at a slant. And if they're going to name it with one capital letter, they're going to put that capital letter right in the corner. So this plane right here, you could name as plane M. Or you can use 3 non-collinear points. So you would have to pick three points that are non-collinear. So you could call it plane. Give me one way to name that. 3 non-collinear points. B, C, D. Tell me why this would be a not so good idea. They look like they're in a line together. So we wouldn't want to use that one. It's either one capital letter, which they would give you in the corner if you're going to do that, or any 3 points that are not in a line. That's how you would name that. So one thing about geometry, very different from Algebra 1 or even Algebra 2, is that it's a very visual math class. So there's a lot of things on paper that you're going to have to imagine in 3-dimension in your head. So it's this shift from doing all of these equations to looking at something very visual, very hands-on, and imagining it in your head. So the next couple examples are really going to stretch your brain in that way, not thinking about equations so much, but thinking about pictures. Okay? So just get ready for that. Anyone still need this? All right, so we don't have to write this down either. Examples of planes in the classroom would be like the floor, the walls, the ceiling, the windows, the whiteboard. Anything that's flat would be a plane. So what I do want you to do is to draw this cube. And if you need help drawing the cube, easiest way to draw them, which you will get very good at drawing pictures, because we're going to draw lots of them, is to draw the front square first. And then some people like to draw the back square up at an angle and then connect each corner. You could also draw your 4 lines back and then connect them on the back so that you get a cube. Get a 3-dimensional cube and then put those 8 letters on there. And then next to your cube, you can write the words front face, and we're going to name that, just like we did on the previous page, naming the plane. So it is a plane on that front face. Whenever we're naming planes, we write the word plane. And we need 3 non-collinear points because they didn't give us one of those capital letters in the corner all by itself. Yes. L, what did you say? L, N? M. Not M, because M is on the back. But what's another one on the front? H. Sure. Okay, so you could pick any of those 4 points on the front of the cube. Grouped together, because none of them are going to be in a line. Okay, we're going to use this same image for an example down here. But before we do that, we have our very last vocab word, coplanar. Collinear meant in a line. Coplanar means all in the same plane. So along with this cube, we have this question or statement here in green. We want 4 lines that are coplanar with NH and JI. While you're writing that down, I will highlight those right here. So here's NH, here's JI. So we're really talking about that right-hand side of the cube. We want 4 lines that are on that one. You have to imagine looking at that side of the cube, turning it in your head and looking at it, and finding 4 lines that you could draw on there. Remember, lines require 2 capital letters. Anyone have any one of those 4 lines on the right-hand side of that cube? NJ is one of them, which is right here. Yep. The other 2 aren't specifically drawn on here, but could be drawn. Let's get 2 new people. Yep. JH. Another new person. Look at where JH is drawn, and you should see where the last one would be. Yep. And I. Questions? Anyone still need this? Okay, we have 1 slide left, and it is not required to draw this picture. We're just going to discuss this. This is similar to a question you will see in your homework today and also on your test at the end of the chapter. So what I'm going to do is give you a 3-dimensional model for this picture. Right here with this piece of paper and a pencil sticking, or a pen sticking through this. So what you need to do is imagine, and I've drawn on the piece of paper the DAC and also the point E at the top. This is plane K. I've labeled it in the corner just like it does in the picture. And on this pen that is poking through the paper, B is up here at the top and F is down here at the bottom. So everyone see that it matches? Okay. Question. First one. Name 3 collinear points. There's actually 2 correct responses to this. 2 different sets of collinear points. So help me out. That's 1 set. Yes. And we're just listing points, so we're just putting commas in between. So those are 3 collinear points. What is another set of collinear points? Somebody knew. 3 points that are in a line together. Emma? EAK. Very good to point that out. Anytime that 3 points look like they're in a line, we can't assume that they are. So I'm glad you pointed that out because that's going to come up in the book. And also, K is actually not a point. It's naming that plane. So it's saying it's plane K, but that's a very common mistake, and I'm glad you brought it up. Yes, Martha? BAF is the other one. So anytime you see a line and there's points on it, you know they're collinear. Okay? Next one. The intersection of plane K, which is the piece of paper, and the line BF, which is the pen. So where do they intersect? is that called? A. Yep, just at A. So they intersect right at that point A. Last question. This one is a brain stretcher. Okay? So really think about this. D, B, A, and C, which are right here, 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 and on the tip of this pen. Are they coplanar? See lots of this. Agree or disagree? One person said this. Yes or no? Argue it. What do you think? Remember, coplanar means that the flat surface touches all of them. So the question is, could a flat surface, imagine a piece of paper or a book cover so that it stays flat, could a book cover touch D, A, C, and B? Yes. Okay. Okay. So D, A, and C, everyone agrees is coplanar, right? All on the same plane. But because this one is sticking out here, we're thinking that it's not coplanar. Could I put a piece of paper in addition to what's here so that it's touching all 4 points? Could I put this plane right here so that it's touching D, A, and C on the original paper, and it's also touching the tip of the pen? Does everyone see that? So a flat surface is able to touch D, A, and C, and B so that it's coplanar. Now, if you're totally like, I don't understand what this lady is doing, that's okay. Because this right here is a very difficult concept to just jump into geometry and be like, oh yeah, I can picture that. Okay, that's not what this whole year is going to be about. I throw it at you at the first day to stretch your brain a little bit, to get you thinking visually and thinking about, okay, here's this picture. Let me try to put it in my mind and be able to turn it around and look at it from the back and look at it from the side and look at it from the bottom. You need to start getting those skills throughout this year. So if you understand it, awesome. Way to go. You're a step ahead of the game. But just know that the whole theme of this year is looking at images, shapes, pictures, and putting math with it. Questions on anything today? All right.